Okay, so thanks a lot for the introduction. I will talk about, what we do on the topic of perovskite silicon tandem solar cells. And just get started, why do we work on, these devices? The reason is that if we want to have a climate or carbon neutral society by 2050, we will have to install 75 terawatt, and which is a lot. Currently, we're a little bit above 1 terawatt. Of course, how do you want to achieve that? By installing a lot of good modules or installing even better modules, and then the quantity, of course, can be a little bit less. Now, another thing is also that actually, what has been a tremendous, I would say, enabler, to come already where we are now. In terms of photovoltaics is, of course, the drop in cost per watt peak. And this is, again, one of the things that we do expect for tandems, that they can drive down that cost per watt peak. But of course, it's not only about efficiency and cost, it's also about reliability. And now we have already for silicon modules that, some companies go from 25 to 30 or even 35 years as warranty. For perovskite PV, we will have to obtain similar numbers, because otherwise it will not be possible to really have a competitive product. So how to make tandems? There's a couple of ways. We focus on monolithic tandems. We're not the only ones doing that. There's also APFL. They use textured bottom cell with solution processed, hybrid processed perovskite, so it's a nice conformal layer what they have. There's also the approach of Helmholtz, that they use solution processing, but to have better quality perovskite, they use a flat front for the bottom cell. And our approach is a little bit in between. So we have a textured, a double-sided textured wafer, and we use solution processing to make the perovskite. And what is also maybe useful to know is that all of the record tandems are in so-called PIN architecture. So basically, the electrons are collected on the front of the device. But it's actually also nice to see is that now it was just last week this article here that I think the hopes for this technology are quite high. This MIT technology review, and they even put this as the second kind of breakthrough technology of 24. But of course, it means that we really have to, we have to fulfill these expectations, and there's quite a lot of work still to be done in terms of reliability, especially. So a little bit in detail, how do we make tandems? So our starting point is a textured silicon wafer, a heterojunction cell. And initially, we worked together with a group of Ted Sargent in a project. And the way how we did it is basically you have a solution, a precursor solution for the perovskite. And what is really important is you need to cover all of these pyramids, because otherwise you would have a shunt path. But by doing that, you can also see that you start to have in some places a quite thick perovskite. And this image already explains you well what is the challenge to really make a good device. You have to make sure, because thick perovskite means that if you want to collect all of the charges, you will have to have a high quality semiconductor, not too many bulk defects and not too many defects at surfaces. And so by making many devices, we then managed to, a couple of years ago, have already a quite good certified efficiency. But for us, this was really now the starting point to, systematically improve this technology. So one of the improvements that we did is, for instance, the bulk, as mentioned, this is, you can have defects. It's polycrystalline material, and for instance, this is work of Jiang Liu, who was a postdoc with me. It's like he used carbazole as the passivant, and it actually brought our efficiency already above 28% certified. For us, we could also start to make now larger devices. It's still, relatively small, but still 2 by 2. We could make, and for us that was also the starting point to do, quite a lot of outer testing. So this is, a photo of our outer field. So we do the encapsulation. We have a number of different devices, reference device, maybe perovskite, silicon tandem, also like single junction devices and so on. And now, some time ago, we also could publish, first outer study for more than a year, or actually for a year. So this is running from April 21 to April 22. And what you see is I mean, first of all, we measure